pull up the slide I had before. So Aaron, I'll give you a second. Just send me an email, a chat, that you can see this display that has a bunch of tables on it, windows. On the left side it says types of analyses, and the right side it just gives more details. So Aaron, if you're still there, just send me a chat or turn on your mic. It's going to take, I'm sure, a second for this thing to come up over there. Not seeing it yet, so let's give it another second. And I appreciate you guys. If you're still there, hanging in there, we will end in a couple of minutes. I'm just going to show you one example. So Aaron, I don't know if you've sent anything yet, but send me an email once you see a slide on your screen that looks like something you saw on Friday night. If not, I will just keep on babbling, and okay, good to go. Okay, so here's what SAS will give you for power and sample size calculations. On the left here, we have a window that says what it can do. It can compare means. It can compare the average, say, continuous outcome, the average quality of life of people in one group versus another group, the average body mass index in one group versus another if you're having an intervention that tries to decrease weight. If you're comparing two proportions, it'll do that. Compare the risk of dying in one group, the risk of dying in another group. It'll do equivalency tests where you're trying to prove that an intervention is just as good as a standard of care. You're not trying to reject the null hypothesis. You're trying to, in some sense, prove the null hypothesis is likely to be true. It'll do sample size for looking at correlation coefficients or regression coefficients. Sample size is for looking at analysis of variance. Linear models, I'm not sure what that gives you. Survival analysis for comparing survival curves. If you click on one of these, like means and location, it brings on the right-hand side the various types of sample sizes it will do. It will do a sample size for comparing a single population to a well-accepted norm. You have one group of people, you give an intervention group, you have no comparison group, you want to compare their outcome to some published result. Or you had two groups you're comparing, but they're matched. Let's talk about the other one, two groups that are not matched. This is the common situation when you end up doing a t-test. So if I click on that, it tells me, do I want to do a one-tailed or a two-tailed test? Let me do a two-tailed test. Do I want to take a log transformation of my data? I'm not going to do that. That's what alpha is. It would be 0.05. It gives me another box. I could try a couple of different values of alpha, 0.05 and say 0.01. It then asks me, if I scroll down, what's the anticipated average result in the two groups I'm comparing? So let's suppose I'm comparing a quality of life measure that's measured on 0 to 100. I expect my intervention to increase the quality of life on average. So maybe it's going to be say it's going to be 90 in one group versus 80 in another group. Or maybe it's going to be 85 in one group versus 80 in the other group. I want sample sizes for two different groups. I then have to tell it, for doing a t-test, the standard deviations I expect in the two groups. Let's suppose the standard deviation in the two groups is, I don't know, 12 points, okay? And now it can calculate either a power for me, in which case I'd have to fill in the sample size that I have in each group, or I could ask to calculate the sample size in each group, and now I would have to tell the power. So let's suppose I want to look at a 90% power, and an 80% power. And let's see if this works. Let me click the calculating button and see if anything happens. It's doing some thinking right now. My screen is showing this. Something is being generated. Let's see how long it takes. Okay, here's the results. It gives me some summaries. What I'm doing, I'm comparing two normally distributed populations, two of them, standard deviations of 12 in all these calculations. Using an alpha of 0.05, if I want to have 90% power, meaning power is 90%. If I'm comparing two groups, which I anticipate to be 10 points difference, I'm going to need 32 people in each group. If I want to have 80% power for that same calculation, I'm going to need 36 people in each group. If the two groups are 85 versus 80, and I want 90% power, I need 123 people in those two groups to have 90% power. If I only want 80% power, I only need 137. you would get similar values using other freebies, other sample size methods on the internet. It actually goes and gives you some graphs of those things, and nicely it gives you a little bit of text you can cut and paste to put into your grant proposal or your paper you're writing or something like that if you want. Now, I'm not going to go any further because time is up, but let me just point out that all these sample size calculations basically assume you don't have to adjust for any factor. They basically assume you're not going to have losses to follow-ups or crossovers or anything like that. They're based on the assumption of a randomized, perfectly done clinical trial, and unfortunately, life is not like that. So chances are when you do these calculations for observational studies, you're coming up with a number, a sample size that's a little bit smaller than you need, or maybe a lot smaller than you need, depending on how much confounding you have, or depending on how much contamination you're having, if you're having losses to follow-ups or crossovers or things like that. And therefore, in the bottom line, it's very difficult to figure out the sample size you need if you have to control for confounding. So typically, people do calculations like this and say, instead of enrolling 123 people, I'm going to enroll 150 people, just to have enough people to, maybe to have enough to control for these potential confounding factors. So I'm going to end here. I'm going to go back to the slide. Aaron, is that you calling me? I don't know if you guys are still with me. Maybe it is.
Hi, Fran, not me.
And Aaron, if you want to turn on your microphone, that was, I think, my wife calling me. I'm going to stop here. And I thank the dozen of you who were here. I wish you a great day.
I didn't get the chance to answer
questions, but if you are going to be in California in February, I hope to see you then. I can put names with faces. Ask me questions then. Or send me questions by email if you want, and I'll try to answer them best I can. But I appreciate those of you who hung in and attended these sessions and others. We appreciate your feedback. Aaron's going to send you a little bit of a survey to ask you about what you thought of these things. I'd be curious in your comments. But I think I'm going to stop here and let Erin go and do her thing. You guys, you must be getting hungry, Aaron. It's you're on East Coast time, so it's dinner time. And I'm gonna shut up. Aaron, anything you want to add or anything? I see your face.
No, I think that's all for me, Fran. I'll be sending out the evaluation to everybody, so if you could send that back to us, that would be much appreciated.
Great. So guys, have a great morning.
Great afternoon.
I hope you enjoyed this. It was fun for me.
I hope you enjoyed this. It was fun for me. Hope to see most of you in California in early February.
Okay, so Aaron, anything?
Okay, so Aaron, anything you want to chat about before we?